So I would say we're not really like learning anything new today. We're just going to do some different kinds of examples. You might notice something. I mean, you might learn something, but like, oh yeah, I never really thought of that. Yeah, absolutely. Have those moments of practice a little bit of the same old stuff and just see some different things that might happen. Oh, there is one new thing sort of that comes a bit later, but it's small. Okay, so, what's going on here? There we go. Remember the discriminant? We talked about that yesterday, so I'm not going to go back over it again. But let's just dive into this and get into the first one. So what am I looking for the first one? Like, how do we start solving an equation like this? It's a degree 3 polynomial equation. Remember, not a function anymore. Functions and equations are related in important ways, but they're not the same thing. Anybody? Anybody? I know you know how to do this. What do I do? Shoy, what do you think? Everybody's thinking about the test and drawing a blank. Well, yeah, we're factoring it. So how do I start factoring? Yeah, that's right. You're. Yeah, so we're going to look for the first factor because we're going to factor it. That's how we solve. We're going to look for the first factor. So go ahead and try to find that. One works. If you just add up the coefficients and get 0, then the 1 works, right? 3 and 5 and 7 is 3 and 5 is 8, plus 7 is 15, minus 15 is 0. So x minus 1. And what do we get left? So I can use this little trick. So this is 3x squared. This is negative 7 equals 0. And the middle term is negative 3x squared. So that's going to have to be plus 8x. Is that right? So this is negative 3x squared. That's going to give me an x squared term. This is going to give me an x squared term. Nothing else is going to give me an x squared term when I expand. They have to add up to that. So what adds with negative 3x to give me positive 5x? Positive 8. But then you have to go back. This is working memory. You have to keep a lot of details in your brain at the same time to do this. Then you have to work back and say, so what times this will give me what I'm looking for, 8x. But it's easy in this case. It's just x. Whoops, whoops, whoops. Okay. Okay, we're good. So what I'm going to do now is b squared minus 4ac. Can somebody do that for me? So that's like b squared minus 4ac. Again, remember, you don't have to show this step in any special way, but 8 squared minus 4 times 3 times negative 7, which is 8 squared plus 4 times 3 times 7. What is it? $45? That doesn't sound right. 148. So what does that tell us? Huh? Yeah, it has 2 distinct roots. It's positive. It's not, if it was negative, that means that's not, you can't go any further. You can't do anything else with it. Hunter? It's not factorable because 148 isn't a perfect square. Very good. So what are we going to have to do? Like, this is an example of why you need to use b squared minus 4ac. If you start trying to factor this, it's not going to work. But there are 2 other answers to this question. You are supposed to solve and find all the values of x that make that equation true. One of them is integer, and the other 2 are not. Not rational either, I should say. One of them's rational, the other 2 are not. But we still have to find them. Mason, what were you going to say? Something? Oh, thank you for letting me know you dropped your pen. Okay, let's do this. So you could do it off to the side or something. And so again, just a quick little demonstration. I don't have a lot of room here, but A equals 3, B equals 8, C equals negative 7. And so that means x Whoops, that's going to add a space for sure. I'll do this part here. So this is like x minus 1 equals 0. And 3x squared plus 8x minus 7 equals 0. Which means x equals negative b plus minus the square root of b squared minus 4ac over 2a. This one's easy. All right, so now I can sub in my values. Negative 8. And if it works out that you have to use a quadratic formula, well, you've already done most of the hard work. Depending on what you're doing, this is something people are going to want to listen to because I'm going to get this question. I'm going to get you asking this anyway, but I encourage you to listen right now. Listen carefully. Depending on what you're doing, you're going to give a different kind of answer. The default is exact answers fully reduced. So if you aren't sure, then do that. If it's a word problem, you're probably not going to be like, he threw the ball and it landed negative 8 plus or minus the square root of 148 over 6 down the field. Like, you're not right. That doesn't make any sense. You're going to find the decimal answer and give that as your answer of how far the ball flew down the field, right? So if it's an application of word problem, you got an answer in a sensible way. You can just decimals, in which case you could just evaluate it here and get your answer. But if it's just a problem that says like solve the following, then yes, exact answers fully reduced is what I would be looking for by default. So we have to reduce this. So how do I reduce this? I'm looking for a perfect square factor of 148. Anybody got an idea? 4? Is there anything bigger? Don't think so? Okay, awesome. So then that works out to, I'll do this once. You're supposed to know how to do this, but I will do it once. So if you're not good at this, watch carefully. 4 times, let's see, that's 25 plus another 12. So is it 37? 4 times 37 gives me 148. And that means I can pull the square root of 4 out. And then I'm going to do this a long way again. You don't have to, but this is still reducible. So the top can be common factored by 2. And so I'm just going to common factor out of 2, bracket, that's negative 4 plus minus square root of 37, bracket, over 6. And then these reduce. So you can skip that step. You don't need to show it. And that's negative 4 plus minus the square root of 37 over 3. And I like to write it as 2 separate answers. I'll tell you why in a minute. It's very easy to see that it has 3 roots. I should, as I'm solving, I would even like do this. So x equals 1, and then those 3, right? I would like, as I'm solving, I should be thinking about how many answers will this have? What's the minimum number? What's the maximum number? And then as you're getting further through the question, after we did the discriminant, we knew, okay, this is going to have 3 answers. We already found 1, but it's got 2 more. And now I've got all 3, so I know I've done it right. People miss the plus minus. Even though you guys have done this for a long time, you're very good at it. We still just forget to write it. Or again, if it's a word problem, it's important to separate those 2 answers and talk about which one is not a viable answer, that kind of thing. It's a really good habit to write it as 2 separate answers. I'm not saying that you would be required to if you got to this step and stopped for this kind of a question. That would get you full marks. But any questions? A little bit of extra work when you have to use a quadratic formula and simplify and you get one like that. Comes up once in a while. Okay, let's try another one. Oh, this one's easy. It's already factored. We can just solve it, right? No? Hunter, you were shaking your head no? Yeah, and why does that stop us? So this is what I was talking about a bit yesterday. Like, it's funny how our brain, even though you know this, your brain plays this trick on you. And either you don't even notice the negative 18 and you just say, okay, so that's 0, that's 0, that's 0. Or somehow you're like, so this is negative 18, or this is negative 18, or this is negative 18. And that's definitely not true, right? So, unfortunately, this is not a super easy question. How are we going to solve it? It looks like it's factored, so you're like, oh, I think this is going to be an easy one. And then it turns out, Alex, what do you think? Yeah, you got to expand this whole thing and get it into fully simplified and then refactor it. And in grade 11, when you do rational expressions, one of the biggest problems people have is not knowing when you have to expand or when you don't. Okay, so this is a moment where you can reflect and think about that. Unit 5 in this course as well would be the same, where you got to think about when do I expand, when do I need to expand, and when don't I? And once it clicks for you, it's actually easy to know when you need to do that. But a lot of people, like maybe over half, go through and they don't really know when am I supposed to expand and when do I not need to, right? So think about that when we're doing this. Start thinking about that as well. All right, so let's go ahead and do this. So I'm going to start expanding. Plus 18 equals 0. And watch, if you get this stuff, watch how fast you can actually do this. So this is 2x cubed. And only, remember, we've talked about this. Only two things are going to give me the x squared term. So what are they? They're that and that. So this is 7x squared minus 2x squared. So that's plus 5x squared. Like, I can do this in one step. And then I get my x term is negative 4x minus 7x, so negative 11x. So that was like this, 7 times negative x and 2x times negative 2. And then 7 times negative 2 is minus 14 plus 18 equals 0. All right, let's see if we can find anybody find a factor? X minus 1, so positive 1 works? That looks like it might be factorable. Did anybody do the discriminant? It's 81. So, yep, it's factorable. Therefore, x equals 1, x equals positive a half, x equals negative 4. Any questions about that? You sure? If there's anything you don't understand, or if I'm going too fast about anything, please ask. Like I know I'm jumping things and I do things fast sometimes because I think that you understand. But just ask me after. You don't have to ask right now. Ask me after. So I don't how you get that, like how you get the half. Like people usually ask, you know, I don't even know how you get the half, right? If I go too fast. Okay. I'm going to speed up. This is B-2. So I'm going to speed this up. I'm just going to factor this quickly. I think, yeah, it works out to x minus 1 times x squared minus 10. Right? Is that what that works out to? Just kidding. I didn't do it that fast. I think that is what that works out. It doesn't even matter if it does or if it doesn't, but I just kind of memorized that. So I think that is what that works out to. So my intention was to let you practice one here, but I want to show you something, so we're going to skip the part. When you factor this, you get something like this. In the last unit, again, listen carefully, because this is a small detail, but it's important. In the last unit, your goal was to factor, and that's factored fully. But now our goal is to solve. Find all the answers that make it true. So here's one. Here's another one. What about this? X squared minus 10 equals 0. Like that, go ahead. Yeah, like that's solvable, right? So it's not factorable, but it is solvable. So yes, you have to keep going for a question like this, and I'm going to show you two quick things. So this one is x equals -2. This one is x equals 1. And there's two different ways that you can think about this, and I just like to talk about it because I think, again, it helps understanding. You talk about this in grade 10, and not everybody understands it, so let's talk about it again. There's two methods that you could use to solve for this. I could isolate, and this is literally like, if I have a bracket that's equal to 0, I don't have to factor fully and then do it. That's usually the process. But at any point in time, I can say that bracket equals 0, so which is what I did here. So that means x squared equals 10, and x equals plus or minus the square root of 10. There's still two answers there. Don't forget that. Absolutely, that you'll lose a mark if you miss one of those two answers. That's method 1. Method 2 would be, you could actually look at that as a difference of squares. It's not a difference of perfect squares, but I could factor it to x plus root 10, x minus root 10 equals 0. And so I could have done that up here at this step and actually got kind of 4 nice brackets and done it that way. And everybody's different. Everybody likes to do it one way or the other way. Whatever you like best is fine. But either way, this still ends up with x equals negative root 10 and x equals positive root 10. I have no preference which way you do it. It's up to you. Yeah?
When you have a bracket that ends up being something like x squared plus 10.
What do you think?
I'm not sure.
What does anybody else think? So this is a very good question. It's a great question. I'm glad you asked. Alex, what do you think? What were you going to say? Same idea. Yeah, like that's not solvable. There is no x that I can put in there that will make that true. And think about that. And on a test, if your brain isn't quite getting something, you have to have skills or something you can go back to, right? Back to basics. So then do this. X squared plus 10 equals 0. That's what we're asking. X squared equals -10. X equals plus or minus the square root of -10, which you're right, is not real number, so we can't solve it. There is an awesome video online about imaginary numbers. If I can find it again, I'll maybe post it, because if you have any interest in mathematics and this kind of thing, and you like this stuff, and you're wondering, there's a huge, like most mathematicians, I think, these days, really don't like the idea of calling them imaginary numbers. They are not really imaginary. They exist. They do exist. And in fact, some people think they're better numbers than the numbers we're accustomed to working for. Well, a lot of people. And you just have to twist the way you think about them to see how they are real. And imaginary is an unfortunate term that caught on. Anyway, so I'll see if I can post it. If you're interested, I really, really recommend it. It really explains imaginary numbers well and visualize them is really, really, really neat. Okay. Two more things. I think we're going to try to wrap this up, so I'm going to go through it kind of quickly. If I am looking for a factor for this, so we won't even bother solving this all the way. You can do it, and I'll put the answer up on the classroom if you want some extra practice. But if I'm looking for factors, let's try 1. Here's a hint, it doesn't work. Let's try -1. It doesn't work. What do I do next? Like you move on to 2 and -2 and 3 and -3, but no, not for this question. Why? Yeah, because remember they have to be factors of 7 as well. So you would skip 2, 3, 4, 5, 6, and you'd move on to 7. And I think either +7 or -7 does work. But actually, there's more to it. So, because there aren't even enough. Think about this. There's going to be 3 answers. There aren't enough factors of 7. Like you could do +7, you could do -7. Well, that even won't work. Like it's not going to happen. Anyway, when you see the answer, you'll understand what I'm talking about. So it turns out that all the factors are of the form m over n, where m are the factors of 7 and n are the factors of 6, right? nx minus m as one of the roots. So a lot of you have actually done this. I've seen you do this. It's like saying 2x minus 3 is the same as x minus 3 over 2 kind of thing. You understand what I'm saying? So I take this. So what would be the list of possible numbers that I could try? Okay, so here we go. It would be 7, and it would be 1, and I could do and then the factors of 6, I'm going to do these over here, are 6, 3, 2, and 1. So these factors are going to be 7 over 1, 7 over 2, 7 over 3, and 7 over 6. And then these ones would be 1 over 1, which we tried, right? Or -1, like positive and negative of both. 1 over 2, 1 over 3, and 1 over 6. Okay, so I bet some of you have no idea what I'm talking about right now, so let me go back over this. So what I'm saying is, let's say, like I think 7 works, but let's say I try 7 and -7 and neither of them work. What do? You would have to try half and -1/2, and then a third and -1/3, or 7 over 2 and -7 over 2. This is the full, those green ones is the full list of possible answers to this. All the factors of 7 over all the factors of 6. Okay? I would never give a question where it was like 12 and 18. There was like a huge list of all the, I wouldn't do that. Okay, so that's not gonna happen. Like again, most of I gotta give you questions that you can solve in a reasonable amount of time. So usually it's gonna be integer factors. But this is something you should still know, okay? That like I might ask on a test to list the possible factors. Does that make sense? Just looking at the equation, what are the possible factors that might be solutions, kind of thing. And then this would be the list that you come up with. Factors of 7 over the factors of 6. Does that make sense? Any questions about that? There might even be one question in the homework where, like, you have to get a half. Something like that, I think. So keep that in mind. Oh, there's a lot of little details to today. Okay, one more thing. We're not going to solve this either. How would you solve that? Sorry, you don't even have to write this down if you don't have it written down. How would you solve this? Very quickly.
We'll just bring it to one side.
Very good. You'd bring everything to one side, set it equal to 0, and then factor and do all the good stuff that we do. right? And you'd be thinking of this as solving an equation. But there's another really cool way of thinking about it, and I want you to think about this. That is a degree 3 function, some kind of cubic relationship, correct? And this is some kind of quadratic. When those two things are equal is where those two graphs meet. So there's your solutions right there. That's one, and that's one. Very interesting, different way of thinking about it. So in grade 10, you learn about solving linear systems. They have one solution where two lines cross, substitution or elimination, right? But I could solve for the point of intersection of any two polynomial functions by having them both in like y equals blah, and then setting them equal to each other. And then you would just move everything to one side, factor, just do it the way that you do it, right? Interesting. This one would be hard. I don't think it, because it doesn't even have, I don't think it has any rational answers, but anyway. Think about that. This isn't in the homework, but it's something I do want you to think about for the next little bit. All right.